Hi everyone, my name is Alexander Borovikov. I'm the Customer Experience Team Lead, and the topic of my presentation is DWG Toolset, the leading DWG solution. A couple of words first about what the DWG Toolset is. First of all, it's necessary to say that it's a mature solution that provides support for DWG, DGN, DXF formats. All standard objects of those formats are supported. Also, there is a set of vertical extensions, and all this allows this toolset to be a base for a variety of CAD solutions with hundreds of products and millions of end users. But that's not all. That doesn't mean that we get relaxed. We put efforts and bring real value on a regular basis, on a yearly basis every year, and that allows us to introduce the features that we're able to call smart ones. Saying smart features, I mean the features that require some background investigations, some complex algorithms implementations, and similar stuff. I'll briefly enumerate the ones that we introduced later. There were options for 3D solid modeling, and dimensions and tolerances, transactions and do-redo, BREP API with extrude and revolve functionality, crypto API, and associative entities. And we just do not add new, we improve the existing ones. For instance, when saying about the complex objects editing, it's necessary to consider a set of complex and dependencies, and all those dependencies should be considered while editing, and recently we improved it, so it's a ready-to-use feature, and as you see, the position is adjusted according to the settings. But as I said, we add totally new features, smart features, and the next one, the smart feature we'll talk now, is the model documentation. This feature could be realized based on a set of complex algorithms like precise hidden lines removal, like associative geometry, and using this feature, you can, for instance, create easily 2D projections of the original 3D model. And connected with the original 3D model by the set of associative geometry entities, all those projections will be adjusted automatically and updated automatically as soon as you change the original 3D model. And model documentation is not limited with 2D projections only. There is a set of auxiliary elements supported that may be implemented using this feature. It's the text annotations, section symbols, detail views, and similar things. And all them will be automatically adjusted, automatically updated as soon as you change the original model. So no human risks, no opportunity to forget something or similar things. The next smart feature that was also recently introduced and implemented for DWG is the common data access. The key advantage of this feature is that it allows to get the properties of the model and to expose the structure of the model by means of the kernel API, not the DWG specific API, but by means of the kernel API. And this screenshot illustrates the left side the model exposed, and the right side the properties of particular entities for this DWG model. And this feature is implemented as cross-platform, so it's possible to use it on all platforms. We also make improvements to the format like DGN, which is tightly connected with DWG, and a set of improvements was introduced for this format as well. Common data access also is being implemented for it. Multi-threaded support for loading and for visualization has been done. API enhancements, and what's I think probably more interesting, the import of the DGN data to DWG. The 3D geometry import was improved, and now we have no need to decrease the complexity of the 3D objects that are being imported to DWG. All the features mentioned allow us to be the base for leading CAD solutions, but what's more interesting, all the features mentioned allows us to be a base for even BIM solutions that are implemented using the DWG toolkit. We also have a set of vertical extensions, and those are architecture, mechanical, civil, and map extensions. Architecture extension is a part of the basic package, thus it's available to all our regular members for a try, and the latter ones are special interest group projects that are distributed under separate license. What the architecture extension is, it has the purpose of easing the architecture tasks, and it operates with the documentation and architecture primitives. As I said, it's a part of basic package and it's available for our members. What the key probably advantages of the architecture objects are? Those objects have behavior, they have connections, and they have styles. When we talk about behavior, for instance, if we have a wall on the window and we need a window, on the wall, there should be a hole that matches the window. And it may be necessary to move the window, and with the behavior feature, the hole for this window will be moved automatically. The similar situation is probably with connections. For instance, if we have a wall and the window in the center of this wall, if we change the size of the wall, the position of the window will be changed correspondingly to be in the center of this wall as well. And when talking about the styles, it's possible to apply a particular style to a set of objects, for instance, to windows and walls. And if we change the style, it changes. This change is applied automatically to all those objects. For instance, we can apply a style for windows only and change windows only, so we decrease the human risks, and so it's easier to operate with the sets of entities. The next extension is the Civil SDK. Civil SDK may be used for complex engineering tasks like road map design, like hydrology, land mapping, and similar things. It operates with civil objects, and civil objects in a similar way like architecture objects. They have all those features like connections, behavior, and styles. We also with the civil project, we are able to visualize all the civil objects, and the creation of the objects is currently implemented partly only, but it's also possible. And as a proof of concept, we also have .NET wrappers. The coverage of the API may be increased if necessary. It's a brief demo. You can see that we're able to open some terrain. We are able to create a road, for instance, and get a set of auxiliary tables with all the appropriate information. The next item is mechanical SDK. It should operate with it operates with mechanical objects, and here we have 27 entities for 7 standards being already implemented. We support versions started from 2013 to 2020, and it's also a special interest group project, so all the priorities, all the standards are set by the members of this group. The list of features implemented in the nearest time includes some improvements with the mechanical standards, the very mechanical database, the erase operation. It's quite a complicated one because it should consider all dependencies and references of mechanical objects. And what's, I think, more interesting even, a dedicated demo application was introduced to ease getting acquainted with the mechanical project and the mechanical SDK. And we also have a map extension that's not probably developed as long as mechanical one, but we are already able to load, pass, and read a map file, and to get all the properties of the elements in that file. We are also able to visualize it So to visualize a model loaded, and for instance, we can compare the results of visualization with the AutoCAD. And as you see, the results are quite similar. But all the features mentioned before were familiar or probably expected, but we also have a set of features that we can call advanced ones because they are not probably so typical. And the first one is the revision control. Everyone who faces a long model development cycle could face a situation when starting with the original model, there appears a set of intermediate states, intermediate names with comments, with attempts to mark the version or so, and it makes the model design quite complicated, and software developers know what to do in this situation. It's just necessary to introduce a revision control system, and Open Design Island's revision control is just it. It's possible to treat it as something like an embedded Git, and the benefits of such approach are quite obvious. It's possible to store all the revision history and to do it in a more efficient way, to use the memory more efficiently. And these benefits are useful themselves, but what's more important, it's possible to utilize them quite efficiently in web and cloud solutions where compact storage and the ability for collaboration, for working together on one model is quite efficient, and we're doing this, we're utilizing it in our web SDK, and together with it we have also visualization in this SDK, and step by step we are migrating all the features and capabilities that we had before, all the features and capabilities that served the industry, that are approved by the industry and served the industry for a long time as desktop applications. We migrate them to cloud, getting them ready for cloud, getting them ready for the future use. And I think one more thing that is interesting as probably even as approach that can be shared, can be analyzed, is the SWIG wrappers. Briefly speaking, we use a third-party tool and put our header files and auxiliary files with the data marshalling rules as an input, and what we get a set of wrappers for our C++ API. And we also already have C# wrappers that may be utilized by C# and Visual Basic developers. We have Java wrappers that may be used for desktop and mobile development. But recently, we also introduced Python wrappers that were successfully generated and approved. And as to me, I'm unaware of some Python API for CAD development, but at least there is one now. And a small demo of this newly introduced Python viewer that is based on recently generated Python wrappers. That's the viewer. We load the model. On the left side, you see the viewer. On the right side, you can see the handlers. The handler that is in charge of zooming. The next one implemented in Python that is in charge of pen. And the third one responsible for the rotation. Briefly, that's it. And another block that is even not just a feature enumeration, it's more, I think, an important announcement is interoperability with Autodesk ReCap files. I think it's clear that point cloud models are getting more and more important. They may be faced as part of being embedded in DWG, but as well they may act as separate files. And when we deal with models that have a small number of points, there are no significant problems. But when we deal with models that include hundreds of millions or even billions of points, the issues even of reading and writing, the issues of visualization, and the issues of performance become quite significant. And here a set of complex measures should be taken, but I can say that we successfully overcome this task. And what we have now, we are able to utilize, to leverage all the benefits of the RCS format. And that was done in the following way. We needed to implement a set of quite complex tasks. The first one was to organize all those points according to a special structure that's called the octree and operates with smaller subvolumes called voxels. Having the structure done and having the overall volume that includes the point cloud model split and organized and structured according to a special algorithm, we get a set of important benefits. First of all, we're able just to filter out all the empty voxels and operate only with the ones that include points. And what is even more important, we can quickly filter out the voxels that are visible for a particular viewport. So that allows to act more efficiently. But it's necessary even to add more efficiency and to deal with a feature that is called level of details. Level of details is the number of points that should be visualized for a particular voxel depending on a particular zoom level. And it was revealed that it's more efficient to have a set of pre-calculated levels of details and to pick up the proper one depending on our zoom level. That will help us to avoid the complex calculations on flight during the actual visualization procedure. And that was also implemented. This thing is calculated and done on the stage of writing data to the RCS file. And a brief demo. That's just a model that has more than 1 billion of points. The size of the model is more than 25 gigabytes. And at least on my laptop, it takes 4 seconds to visualize it. It's the Mega Trading Center. And as you see, we were able to filter out, and for this particular view, we do not need the entire 1 billion of points, but about 70 million only. That gives us the opportunity to visualize it quite quick and to proceed with it efficiently. The rotation without gaps, so similar things. And additionally, we would like to show that we support the zoom. And if necessary, it's possible to call the regeneration to switch to another level of details to increase the number of points to have a more detailed picture. For this time, it may take some time, I think. But point cloud models support not only just points, they also support colors of these points, and we will show it during our live demo. We will open an actual model during a live demo. It's a model also with several hundreds millions of points, or about that. And that's colored ones, so we can see a part of the city, the cathedral, the park, and similar things. And no need to say that this opportunity discloses, it's possible to say, the RCS world, because if you know the format of a point cloud file that you are dealing with these capabilities, you can convert it to RCS and leverage all the RCS benefits efficiently. Probably change the level of details, probably. Some zoom. Okay, so I think that's it. The live demo may be closed. We'll be glad to answer your questions if there are. Thank you for your attention.